So back to Chapter 7, Analytic Geometry. And now we're going to learn about the ellipse, which is another one of the conic sections that we are going to study. So let's learn about ellipses. That's the plural. So we're first going to analyze ellipses. And again, we start out simple by analyzing ellipses with the center at the origin. And then we're going to analyze ellipses with the center at a point HK. And again, H is going to make a horizontal shift and K is going to make a vertical shift. And then we're going to solve applied problems involving ellipses. So I'm going to show you another interactive figure talking about how an ellipse is created. And every point on an ellipse, if I measure from the focus to the point on the ellipse, and from that point on the ellipse to the other focus, and I add these two distances together, they stay constant all the way around the whole ellipse. So you can actually make an ellipse by putting two fixed points like this and taking a piece of string that's this long, putting a pencil in there and moving the pencil around to its fullest extent, and you will draw an ellipse. So here's the standard equation of an ellipse. And the important thing is not necessarily which way it's larger. It's that under the x squared term comes a squared, where plus and minus a is the distance you go in the x direction to get from the center to the end of the ellipse. Then under the y squared term is b squared, and you go plus and minus b in the y direction, so from the center to the top and bottom. Always in the y direction if it's the number under the y. So I don't call them a and b in my mind. I just say the number under the x squared and the number under the y squared. And this, to me, is an awkward way to write this equation. So I like it better to say that a squared is b squared plus, well, let me try that again. That c squared is a squared minus b squared. So see how there's a difference here in the c squared formula, but there's a plus here in the ellipse formula. So this looks similar to the Pythagorean theorem, but it has a difference in it. And there are triangles involved in the proof of why this is so, but this c number, plus and minus c, is the distance from the center to focus. So look at all these c's. Distance from center to focus. So c is the distance from center to focus. Always. And c squared is the difference of these two denominators. So do you see how it doesn't really matter what their names are? They have to go whichever way it will make a positive number, because c squared has to be positive. It's a squared number. Okay, so for the rest of the section, the directions will just say analyze the equation, and we'll know that it means find the center, find the major axis, so the longer axis from one end to the other, that's called the major axis. The foci, so the plural of focus, is foci or foci. Either one is correct. And then find the vertices of the ellipse. Well, notice that the vertices, it has 4 points that help us draw it. The b and the minus b and the a and the minus a. But only the points the farthest away from the center are called vertices. So one vertex, plural vertices. Okay, so these instructions say find the vertices and foci of the ellipse and graph the equation. So we can see under the x squared is a 9, so a squared is 9, and a is plus or minus 3. So the center's at the origin, and we go 1, 2, 3 in the x direction, 1, 2, 3 in the y direction, and we find points on the ellipse. Don't forget to label your axes. Then under the y squared number, we see that b squared is 4. So b is plus or minus 2. So that's how far we go in the y direction. 2, up 2, and down 2. And then we can draw our ellipse once we have those 4 points. And do work on making your ellipse have twofold symmetry. The part in quadrant 1 and quadrant 2 should look symmetric over the y-axis. And the part in quadrant 1 and 2 should look symmetric to the part in 3 and 4 over the x-axis. It's hard to do and it takes a little practice, but you can do it. Okay, so now I look at my graph and I say, well, I can see from the graph that the vertices are negative 3, 0 and 3, 0 because they're the points the farthest away from the center. Well, now we need to find the focus point. So c squared is going to be that distance that we want, and it's going to be the difference of the denominators. So c is going to be plus or minus root 5. And we can see that that's between 2 and 3, a little closer to 2, right? 2 is smaller than root 5 because root 4 would be 2. And root 5 is smaller than 3. So it's in between 2 and 3, closer to 2. So somewhere about here. But this distance is root 5. So here's a focus point. Here's a focus point. That distance is root 5. So we can call them focus 1 and focus 2 if you like. So the coordinates of the focus points, or the foci, or foci, is negative root 5, comma 0, and root 5, comma 0. So for me, I'm okay if you write plus or minus root 5, 0, but I don't think my math lab will interpret that correctly. So let's look at number 28 together, because that's a little trick here. I call these the puzzle problems, where you're given some bits of data and you have to put them together and figure out what the ellipse must look like. So here's the ellipse that's longer the other way, but again, I really don't think of these as two separate cases. I just say that the c squared, see, they say it's a squared minus b squared, and they put the a squared under the y squared this time. I just say it's the bigger one minus the smaller one, because I know it has to come out to be a positive number. So everything else is the same. The points the farthest away from the center are the vertices. The difference in the denominators gives you the square of the distance from the center to the focus. Okay, so here's one where it's not quite in standard form yet. The equals 1 part is essential. So we need to divide both sides of this equation by 36 before we can even get started. So I'm going to have y squared over 9 plus x squared over 4 equals 1. And I know my vertex is still, my center is still at the origin, because we're doing the simplest problems first. So in the x direction, I go plus and minus 2 from the center. So plus and minus 2 from the center. In the y direction, I go plus and minus 3 from the center. So I can already see that the vertices are going to be 0, 3, and 0, negative 3, because those are the points the farthest away from the center. And again, do your best to try and get the symmetry that should be happening with an ellipse, but I know it's hard. Mine are especially bad with this stylus. Okay, so then focus points are always along what's called the major axis. So in this case, the longer axis is the major axis. So I know the focus points have to be on that line. And if I want to know how far away they are from the center, I say c squared equals 9 minus 4, which is 5. So c again is plus or minus root 5. So it's a little farther than 2 away from the center. That's exactly root 5. So here's focus 1 and focus 2. So it looks like the focus points are at 0, root 5, and 0, negative root 5. And then we've already got the graph done. That's why I like doing it in that order. My graph's already done when I get there. Okay, and then let's do number 30 together in class, because again, that's a puzzle problem. So here's all the information about ellipses kind of collected together in one place. And this is if we let the center move. So notice that if the center is HK, that the whole ellipse goes with the center. So it's been shifted H horizontally and K vertically. Okay, but now the vertical shifts are working like the horizontal shifts did when we were doing functions. So just be aware of that. Okay, so we do need to be able to write an equation for an ellipse. And here we have one number 40 where the center is at -1, -1. So I'm going to have x minus the x coordinate of the center. So that's going to be 1 squared over something. Y minus the y coordinate, which is -1. So that's going to be y plus 1 over something equals 1. Well, we can see that in the x direction, from the center to the edge of the ellipse is 1. So this is going to be 1 squared. And on the y direction, 1, 2. So this is going to be 4. So typically we don't write divided by 1 because it's just kind of a waste of effort. So this would be the equation for that ellipse. And once again, you can use Desmos to check your answer. So I'd encourage you to do that, in fact. Okay, so let's look at number 44. And we can see that the center is -4, -2. So the center is going to be at -4, -2. Label my graph. Under the x coordinate, I see 9, so I go plus or minus 3 in the x direction from the center. And under the y, I see 4, so I'm going to go plus or minus 2 in the y direction from the center. Okay, so I found the center. I can tell you what the vertices are by looking at my picture. Looks like -1, -2, because the vertices are the points the farthest away from the center. And then -1, 2, 3, 4, 5, 6, 7, -7, -2. And notice that the y coordinates are lining up because I can see that those points are in a line that would be y equals -2. So all the y coordinates better be -2. And then I need to find the foci, so I need to find the c² number, which is the difference in the denominator. Sorry, these all came out the same, but there's not that many variations. You'll see as you do the homework. So c equals plus or minus √5, always along the major axis. So there's one focus here and one focus here. But now notice to write the coordinates of the points, you have to say, well, I'm starting at -4, and then I'm going plus √5, and the y coordinate staying at -2. Or I'm going at -4 and I'm going backwards square root of 5, and my y coordinate is staying -2. So you could say -4 plus or minus √5, comma -2 for me, but my math lab's not going to like that. And then don't forget to actually draw the ellipse. And notice that when the a² and the b² are fairly close to each other, the shape is fairly close to round. That's actually something that is important that you'll study more in trigonometry. So let's do number 50 together in class, because that's when we're going to have to do complete the square. And let's do these puzzle problems together in class also.